In this video, we're going to take a look at adding and subtracting rational expressions. So first, let's just take a look at two basic examples. So in our first basic example, we have 2/3 plus 1/2. So in order to add fractions together, you have to get a least common denominator. So between 3 and 2, we could turn them both into 6. So I like to write them down and then think of what I would need to multiply the fraction by to get a 6 in my denominator. So 3 times 2 would give me 6. And then I also need to multiply the numerator by the same number. And remember, 2 over 2 is equal to 1. So that's why that's okay to do it that way. So we end up with 4 over 6, which is equivalent to 2/3. So really you're not changing what you have, you're just changing it so it has a common denominator with the other fraction. So the fraction on the right, we need to multiply 2 times 3, and then also multiply the numerator by 3. So we end up with 3 over 6, which again is equivalent to the 1/2 we started with, but now they both have a common denominator of 6. So let's bring that over and then combine the numerator. So 4 plus 3 would be 7. Okay, let's look at another basic example. So we have 3/5 plus 1/4. So we could turn 5 and 4 into 20. So I'm going to write that down, and then I'm going to multiply the fraction on the left by 4, since 4 times 5 gives me 20, and 4 times 3 would be 12 in my numerator. And on the right, I'm going to multiply by 5, since 4 times 5 is 20, and then 1 times 5 in the numerator would just be 5. Then we can add those together. So keep the 20. They do not add up to 40. They just both needed to have a 20 in the denominator so that you could combine the numerator, and we just get 12 plus 5 is 17. All right. So in order to add or subtract rational expressions, we're going to determine the least common denominator, similar to our basic examples we just looked at. We're going to then multiply each fraction by what it takes to get that least common denominator, and we need to multiply the top and the bottom by the same thing. Then we're going to keep the least common denominator and combine the numerators, and then write the expression in the most simplified form and state the restrictions on the variables. So let's look at these first few examples. These number 1, 2, and 3 all have common denominators already. So if you're given an example like that or a problem like that, you can just go ahead and combine them. So recognize when you don't need to do extra work and don't do that. So we would just write xz to the 4th because that's our common denominator, and then 5 minus 6 is -1. And then we could state the restrictions, like what would make this denominator equal to 0. So x could not equal 0, because if that was 0, 0 times whatever is right beside it would give you 0. And the same thing for z. Z can also not equal 0, because 0 to the 4th power would be 0, and then that times anything that x would be would also equal 0. So we have x can't equal 0, z can't equal 0, and then our simplified form of our answer. All right, so for number 2, they both have a denominator of x minus 8. So we just bring those over. Like the x minus 8 stays the same. Then 8 plus 2 would give us 10. And then we just need to state the restriction on the variable. So x cannot equal 8, because 8 minus 8 would give us 0. So 8 is not a possible value for our variable. All right, and then let's look at the last example like this type with 3x is our common denominator. So let's bring over 3x as the common denominator. And then we have in our numerator things we need to combine. So we have x minus x. So that just cancels out. And then we have -9 minus 6. So -9 minus 6 would be -15. But then we could reduce that a little bit, because -15 divides evenly by 3. So in other words, we could say -15 is -3 times 5. And then we have 3x in the denominator. And then these 3's can cancel out. So you're just dividing the top and the bottom by 3. So we can simplify a little bit. When you can simplify, you want to do that. And then we just have to say x cannot equal 0, because that's the only value of x that would make these denominators equal to 0. 3 times 0 would equal 0. So x can't be that value. Okay, so let's look at some that are just asking us to find the least common denominator, but don't do more than that. So that was the question, and we were looking at 5 over 3 and 2 over 7x. The least common denominator is what can we turn 3 and 7x into so that they are the same, and that would be 21x. But that's all we have to do for that problem. For number 5, we have 3 over x and 2 over x minus 4, so the least common denominator would be x and x minus 4, because there's nothing you could multiply x by and get x minus 4, and there's nothing you could multiply x minus 4 and get just x. So we just need one of each for our least common denominator. And that's similar to number 6. We have x plus 8 and x minus 8. There's no way to turn one of those into the other, so we just need one of each. So our least common denominator would be x plus 8 and x minus 8. Okay, so let's look at a few examples of where we do need to put them completely together and do all the steps. So on number 7, we have 9 over 14y minus 5 over 2. So the least common denominator would be 14y. Think about, you can't ever have less than one of your denominators, but could you turn the other one into that one? So like 14y, I can't ever have anything smaller than that, but could I turn 2 into 14y? And I can, because I can just multiply it by 7y. So 14y stayed the same, so I bring down the 9, and then 5 times 7y is 35y. And then I want to combine numerators and keep that least common denominator. So 9 minus 35y doesn't actually combine. Those are not like terms. So just write them down like that. Don't make up new rules. And then y cannot equal 0, because that is what would make that denominator 14y equal to 0. And if you ever need to figure out what your restricted value is, you could just set the denominator equal to 0 and solve for the variable, and that'll tell you what your restriction is. So see how y equals 0 in that case? Y can't equal that. So we're done with number 7. Let's look at number 8. We've got 3x plus 15 and x plus 5. So our least common denominator is a little, you might be able to tell what it would be from there, but you could also factor out a 3 first, and it might show up a little clearer. So 3 times x plus 5 is our common denominator, or 3x plus 15, either way. Because we can multiply the fraction on the right by 3, and it'll look like the one on the left. And so if we can do that, we want to do that since that's the easiest step to take. And so let's bring down the 4x, since the first fractions stay the same, and 7 times 3 is 21. And then we can combine the numerator and keep our denominator that's now the same. So 4x plus 21, again, those are not like terms, so just bring them over into one numerator and leave it like that. There's nothing more we could simplify with that. And then we just have to state that x could not equal negative 5, because negative 5 plus 5 would equal 0. And we cannot have a denominator equal to 0. All right, 2 more examples to look at. So number 9, we've got denominators x minus 5 and x minus 5, x plus 7. So x minus 5, x plus 7 is going to be our least common denominator. We could definitely make them look like that, because the one on the right actually is already that denominator. So let's just bring down the numerator. The one on the left, we just would need to multiply by x plus 7 on the top and the bottom. So 1 times x plus 7 is still just x plus 7. And then let's combine the numerator and keep the denominator as our common denominator. So x plus 2x would give us 3x, and 7 minus 22 would be negative 15. So in that case, I can tell that 3x minus 15, I could factor out a GCF and see if that would help me to simplify this expression just a little bit more. So we want to check on that. So let's take out the 3, And then we have 3 times x minus 5. And x minus 5 is now a common factor in the numerator and the denominator. So we're able to simplify just a little further and say that our most simplified form of our answer is just 3 over x plus 7. And then we leave it like that. And then looking back at our denominators, we have x minus 5 and x plus 7. So x cannot equal 5 or negative 7 would be our restricted values. All right, so last example, number 10. We have 3 times y plus 3 and y plus 1. So in order to make these the same, we just need one of everything. We need 3, we need y plus 3, and we also need y plus 1. So let's just write that twice and get ready for our common denominator in the next step. Put a minus in the middle because that doesn't change. And then we just see what would I need to multiply by to get these to match. So I have 3 and I have y plus 3 on the left. I need y plus 1 to make them look the same. And on the right, I'm going to need a 3 and a y plus 3. So we just multiply top and bottom by that. So I'm just going to bring down y plus 1 times y plus 3 for my first numerator, and then 7 times 3 would give me 21, and then bring down y plus 3 for now. All right, so let's do a little work to clean these numerators up a little further. So y plus 1, y plus 3, we need to take and FOIL it. So if you like the box method or the FOIL method, either one will work. I'm just going to FOIL it this time. So I get y squared, I get 3y plus 1y plus 3. So then that's y squared plus 4y plus 3. All right, so I'm going to put that back into my numerator. Y squared plus 4y plus 3. I'm going to keep the denominator like it is because we're just working on the numerator right now. And then I'm going to distribute the 21 to the y plus 3. So I get 21y plus 63. And again, keep the denominator like it was. Okay, so now let's combine the numerator and keep the denominator and see if we can simplify. So I'm just going to bring down that denominator one more time. Keep writing it like it looks. Don't multiply it together. All right, so I have y squared. That doesn't go with anything, so I'm going to bring that down. Then I have 4y minus 21y. So 4 minus 21 is negative 17y. And then I have 3 minus 63. So 3 minus 63 is negative 60. And so that looks like a basic trinomial. I'm going to figure out what could I multiply to be negative 60 and add up to negative 17 to see if I could simplify this a little further. So I'm just going to bring the denominator over again and think about multiply to get negative 60, add up to negative 17. So that would be y minus 20, y plus 3. And then I notice that I do have a common factor of y plus 3 in the numerator and in the denominator. So I'm able to reduce this to y minus 20 as my numerator, and 3 times y plus 1 is the denominator. And you do want to simplify if you can, so that's the best simplified form of the answer. And then let's just state the restrictions on the variable. So if I have a denominator of y plus 3 and y plus 1, y cannot equal negative 3 or negative 1. All right. So that's it for adding and subtracting rational expressions.